Hi everyone, we're starting our next section, section 8E, on quadratic trinomial factorization, which is otherwise known as sum and product. Okay, so what we're going to be taking a look at today is a quadratic trinomial. So a quadratic trinomial has the form of ax squared plus bx plus c. So what that means is we have an x squared value, we have an x value, and we have a constant. Okay? And the values a and b are our constants, and x is our variable. Okay? So x and x squared. Now, our value of a doesn't equal, or it can't equal 0, because if we made our value of a here equal to 0, we would no longer have a quadratic. Okay, because a would go to 0, 0 times x squared would make that disappear, and we would just get bx plus c. And bx plus c is nothing more than a linear equation. All right, now, if we were going to expand x plus 3 times x plus 4, okay, what we would end up getting is we would end up getting x squared plus 3x plus 4x plus 12. So what does that mean when we're using FOIL? It means that these two numbers here, so 3 times 4 gives us a product of constants, and then the 3x plus 4x, which then get added up together to give us 7x, okay, they are a sum of the x's. All right, so basically we've got a product here, a multiplication, that's 12, and a sum that's going to equal 7. So the question basically is, okay, so if we were looking at this backwards now, if you were given x squared plus 7x plus 12, the question would be, what two numbers multiplied together give us this product of constants, which is 12? So what two numbers multiplied will give us 12, but those same two numbers added together are going to give us 7. So again, the middle x part is addition, and the constant is a product, so that what two numbers multiplied give us 12 and added give us 7. So what you're going to start looking for are all the factors of 12. So you're going to start saying, well, 4 times 3 gives me 12, and 6 times 2 gives me 12, and 1 times 12 gives me 12. But if I were to do the sum of these numbers, the only one that would give me 7 would be 4 and 3. The other one would give me 8, this one would give me 13. Therefore, I need to look for two numbers that multiplied give me 12, but added equal 7. And the numbers happen to be 4 and 3. So what we would do is, because we're factorizing, and that means we're bringing back the parentheses, then we would start with an x and an x in both parentheses, and that's simply because x times x gives us x squared. Okay, so we put an x and an x in the parentheses, and because we have x squared plus 7x plus 12, because everything is positive here, then I know that everything is going to be positive inside both of these parentheses. And then the last thing I'm going to do is I'm going to write down 3 in the first and 4 in the second, or vice versa, so that if I were to multiply these through again, I should be getting back to x squared plus 7x plus 12, which is up here. All right, so let's try doing another example. All right, so the example would be if we've got x squared plus 8x plus 15. So remember, we always put them in order from biggest degree, from squared to x to the power, so x to the power of 2 to x to the power of 1 to x to the power of 0, or no power here. So it's x squared plus 8x plus 15. So that we're looking for two numbers that added will equal 8, or not 8x, but they just equal 8, and multiplied they equal 15. So I start writing down, well, 5 and 3 give me 8, or multiply to 15, so I think that's the answer. And then 1 and 15 would be the other solution. But when I add 1 and 15 together, that's going to give me 16 as a middle term, so that's not going to work. If I do 5 times 3, that gives me 15 as my product. And when I do 5 plus 3, that gives me my middle x term, which is 8. 5 plus 3 is 8. So we would open up the two parentheses, and we would say, well, it's an x squared, so it goes to x and x in both of them. And because both of these are positive, then this will go to plus 5, plus 3, and plus 5, or plus 5 and plus 3. All right, let's try another one. And again, there's explanations here. So the question is, what two numbers multiplied together give us 15, and those same two numbers summed up or added together equal 8? So we look for all the possible factors of 15, and then when we find the combination that sums up to 8, which is 3 and 5, then the two binomials are going to be x plus 3 and x plus 5. And to check if this is right, all we need to do is FOIL the two parentheses, and the result should be x squared plus 8x plus 15, which it is. All right, let's try another one, so that we've got x squared. Whoops. So that we've got x squared plus 5x plus 6. All right, so x squared plus 5x plus 6. Again, we are looking for two numbers that multiplied. So multiplied, they are going to equal 6, and added, they're going to equal 5. So I look for all my factors of 6. They're 1 and 6, and 2 and 3. Now, which of these is going to give me a sum of 5? So 1 plus 6 would give me 7, and 2 plus 3 gives me 5. So I know this one is going to work. So then I'm going to end up saying that I'm going to open up the two parentheses, for both with x inside. They're both going to be positive, and therefore it's going to be x plus 2 and x plus 3, or x plus 3 and x plus 2. All right. Now, this method is called the sum and product method. All right, so if we wanted to do these next ones, now we have something a little bit different here, because in these ones we are looking at also some negatives. So let's take a look at the first one, which is just a positive, but let's look at it anyways. So it says we've got x squared plus 9x plus 14. So what are all the factors of 14? Well, it's either 1 and 14 or 2 and 7. When I sum these up, this would go to 15, this would go to 9, and since I'm looking for a sum of 9, that means that the two numbers must be 2 and 7. 2 times 7 gives me 14, 2 plus 7 gives me 9. So that I can write x plus in this case, and then 2, and then 7. And then 7 in the next one. Now, let's take a look at the next one. The next one says x squared. We've got x squared minus 5x minus 14. All right, so now I've got definitely, now because I have a product that is a negative, that means that one of the parentheses has to be negative and the other one is going to have to be positive, because the product is negative. So a negative times a positive will always give me a negative. If I have positive times positive, it would give me a positive, and if I have negative times negative, it would give me positive. Therefore, I have no choice. It must be one is negative and the other one is positive. Okay, so again, we look for all the factors of negative 14. So the factors of negative 14 could be negative 7 and positive 2. It could be negative 2 and positive 7, 7 and negative 2. It could be negative 14 and 1, or 14 and negative 1. Now, when I do the summing of all of these, they have to sum up to negative 5. And it would seem that the one that would work would be negative 7 and 2, because that gives me negative 5. This would give me 5. This one would give me negative 13, and this one would give me negative, and this one would give me positive 13. Okay, so that my answer then is going to be x minus 7 and x plus 2. All right, and if we take a look at the next one, now, the product, if we look at it, is 20. It's positive 20. But the sum is a negative number. So because the sum is a negative number, but the product is positive, these must be both negatives, because a negative times a negative will give me a positive when I multiply it through. So I have x, and the numbers that... So the next one then has an x minus and an x minus. Now the sum is negative 9 and the product is positive 20. So the two numbers are going to have to be negative. So it can be either negative 20 and negative 1, or negative 4 and negative 5, and that pretty much covers it. Or negative 2 and negative 10. Now, this will give me negative 21 when I add them. This will give me negative 9 when I add them, and this will give me negative 12 when I add them. Therefore, I'm pretty certain that the answer is going to be negative 4 and negative 5. So my value of the sum and product, or my factorized form of x squared minus 9x plus 20, is x minus 4 times x minus 5. All right. Now, all the questions that we have looked at so far always had the value of the a here, which was equal to 1. Now that's an important thing to keep in mind. When your value of the a is always equal to 1, then it's easy to use sum and product. But when my value of the a is not equal to 1, what I absolutely need to do is check to see first if there is a common factor to remove. Okay? Because if there is a common factor to remove, then it becomes easy. So that if we look at this example, 2x squared minus 6x minus 8, our value of the a in ax squared plus bx plus c is not equal to 1. So what we do is we try to remove the common factor first. So I have 2 bracket x squared minus 3x minus 4. So now what I do is I leave that 2 on the outside of the parentheses, and I concentrate on factorizing the inside part. So I'm going to be looking for two numbers that multiplied together give me negative 4, but the sum of those two numbers gives me negative 3. So because the multiplication is negative, and the addition is also negative, that means that one answer, or one of the two parentheses, has to be positive, and the other parentheses has to be negative. So I'm going to start by saying, I will start by saying 2 times, because it's referring to the 2 that we took out, and it'll be x minus, and then I'll have an x plus. Now, the only numbers that will give us a product of negative 4 are negative 2 and 2, 2 and negative 2, 4 and negative 1, or negative 4 and 1. Now, 2 and negative 2 will always bring my answer to 0 for the x when I sum them, so it can't be the 2's and negative 2. And the only one that works is negative 4 and 1, because negative 4 times 1 does equal negative 4 when it's multiplied, but when I do negative 4 plus 1, it gives me negative 3, the sum in the middle of negative 3. So it'll be x minus 4 and x plus 1. All right, we're just going to do a couple other ones. Let's take this b here. Let's take part b. So that part b says, I've got 3x squared minus 6x minus 24. If I take off, if I remove the 3, there's a common factor. This goes to x squared minus 2x, and it's going to be minus 8. So I'm looking now for two numbers that multiplied together give me negative 8, but added give me negative 2. So it's going to be x, there's going to be a negative, and there's going to be a positive. And 4 times 2 gives me negative 8, or negative 4 times 2 gives me negative 8. Negative 4 plus 2 gives me negative 2. Therefore, my answer is 3 times x minus 4 times x minus 2. Now, let's take a look at just one more example. Let's look at the one where we've got the negative x squared minus 3x minus 2. We are absolutely going to have to take out the negative first, so we get x squared plus 3x plus 2. Now, I take a look at this, and I say, okay, what two numbers multiplied give me 2 and added give me 3? And added give me 3, so that I end up with negative bracket, so it's going to be a positive and a positive for both of them, and it'll be 1, and it'll be 1 and 2. 1 times 2 is 2, 1 plus 2 is 3. All right, let's take a look at F, where we can remove an x squared, and what's left over is an x squared plus 2x plus 1. All right, now taking a look at this, we're finding that this inside the bracket can be can be factorized even more. We've got a quadratic trinomial. So what two numbers multiplied give me 1 and added give me 2? Well, it's actually a perfect square. It's x plus 1 all squared, and there's the x squared on the outside, which is being carried over. All right, now if we have a question like I, so we're going to take out the negative, all right, and we'll have 3x plus 2 plus x squared. But before we do anything else, we need to put these in the correct order. So we'll go to negative bracket, x squared plus 3x plus 2. And x squared plus 3x plus 2 is just going to be, when we factorize that, it'll be the negative on the outside. It'll be x plus 2 times x plus 1. 2 times 1 is 2, and 2 plus 1 is 3. All right, I'm done. Just remember to place these in the correct order of x squared to x to the constant, and we're looking for the two numbers that multiplied equal the constant, but those same two numbers added together equal the middle x term. Okay, I'm done. What you're responsible for is exercise 8E in your textbook. All of it in the MYP4 text. See you later.